Alrighty, welcome everyone. First of a bunch of sessions we've got on running Docker on Azure. So what we are going to go through was working. So we're going to cover a number of things, two high level. So one, we're going to look at the options for running Docker on Azure. So from just running Docker in virtual machines, leveraging things like VM extensions, and also Docker machine, we'll look at Docker support across kind of all of the Azure compute services, which services are Docker enabled. We'll have a look at Azure Container Service, which is about deploying container orchestration environments. So we'll have a look at that, and then we'll also look at some of the surrounding support systems that Azure provides for running containers. So first section is where you can run containers, and then the second section is really on supporting services like Azure Container Registry, Operations Management Suite for aggregating logs, and using CI/CD solutions like Jenkins and Visual Studio Team Services. So my name's Ken Thompson. So I'm an Azure Technical Specialist in the Global Black Belt team at Microsoft. I look after open source software for Australia and New Zealand. I joined Microsoft from Red Hat, and prior to that I was at Accenture, so kind of varied experience on cross open source and Microsoft technologies before I was at Red Hat. I run the Kubernetes and Ansible meetups in Melbourne. So it'd be safe to say you'll know which container orchestrator is my favorite, although we support them all. Got two kids and keen gamer, love Raspberry Pis, so do a lot of projects with them. My favorite is RetroPie, which is a retro arcade emulator compiled for the Raspberry Pi, so it tops my arcade system. And then I'm working on a NES cartridge is my next project, so I can take it around to mates' places. Speaking of Raspberry Pis, make sure you fill in your event survey and event feedback, really important, but I've also got some open source feedback surveys. So if you go to aka.ms/OSS feedback, bunch of simple questions just to get a feel of what you guys are looking at in terms of open source software, especially on Azure. And there's some open source swag, so some shirts and Raspberry Pis up for grabs. So this isn't my updated deck, so we'll come back to that. All right, so first, I'm assuming everyone here's heard of Docker. So who has done a Docker run? Hands up. Okay, keep your hands up if you've done built a Docker file. Okay, so almost the same, so that's good. So I guess for those who are newer to Docker, the real value proposition for Docker is that it provides a consistent way to package your code, whether you're a .NET developer or a Java developer or a Python developer. And from an operations point of view, it provides a consistent artifact to run code packages from your dev teams, whether they're .NET teams, Java teams, etc. Now, that is kind of all about adding consistency to environments. So if I run the Docker container on my local laptop and I push it to test and I push it to production, it's going to run exactly the same because we've got more control around the container, the application and its dependencies. So if we look at containers versus virtual machines, apologies, this isn't my updated deck. All right, so virtual machine, you've got a hypervisor. We run a host operating system inside there, so it might be Linux or Windows. Then we install our binaries, so this might be a Java runtime environment, and then we install our application on top. So where you run into trouble there, especially as you're moving through environments, is that you have inconsistencies around host operating system, the libraries that are installed, the version of the supporting runtimes, Java, etc., that are installed. And configuration management tools certainly help alleviate this, and Docker is another method that you can get around the differences in environments by bundling that. So then we bundle at least our dependencies in our application as a Docker container, or there's other container formats around. So the difference is we're not packaging the host operating system. So we're running the container on top of a shared kernel. So we have multiple containers in an operating system, and you can really just think of them as multiple instances or services on that same operating system. So by not having the host operating system, virtual machines will measure in gigabytes, and containers usually we're measuring in megabytes. So they're much slimlined. They're a little bit more portable because we can spin them up more quickly. But we still have isolation in the kernel, so we'll touch on a couple of those sections coming up. So a couple of semantics. So a Docker file is a text file, which is YAML structure. So Scott talked about in the keynote. It defines how to build your Docker image. We'll have a look at one of those in a little bit, and then a Docker image is basically the package format of that Docker file. So how we define how we want to build our application in the Docker file, and then we build that file, and that becomes a Docker image. And then we push that image to a Docker registry, which is like an artifact repository. And then when we do a Docker run and we're running that application on the server, that is what's called a container. So that's just the difference between a Docker file, Docker image, and Docker container. And let's do that one first. So Docker's roots definitely comes from the Linux operating system. Docker didn't invent containers on Linux. They've actually been around, some of these technologies like maybe not C groups, but namespaces certainly has been around for 5 to 10 years in the Linux kernel. What Docker's provided is a really easy way for developers and operators to use these container technologies in the kernel. So previously you had to do some specifics, semantics in your code to enable things like control groups. And Docker just made it so you can do a Docker build and Docker run, and it magics all that away for you. It's quite good. So the technologies that in play in the Linux kernel, we use control groups or C groups. So they're actually born out of Google. They contributed them to the Linux kernel. So they provide the ability to restrict resources for containers, so we can control how much memory it's using, CPU, network I/O, things like that. We use namespaces to provide segregation between containers. So the container can only see within its namespace, so it can't see other processes on the operating system or processes in other containers. And that's the technology we're using there. If we look at the Windows world, so we introduced Docker support into Windows Server 2016, so that's now generally available, and we're also providing supports backed by Docker Inc. as well. And we're using similar technologies in the Windows kernel, which have been around in the Windows kernel for a while, but we never exposed them to the users. So again, control groups, we're using job objects instead of C groups. We still have concepts of namespaces and layered file systems. So similar ways that we're executing the same function. And if we look at the Docker engine up top, so when you're actually doing a Docker run, Docker build, that's interfacing into the kernel for you. So you don't need to worry about this stuff. It's just background around the differences between the different architectures of Windows and Linux. So we're working quite closely with Docker. We've got a number of their offerings on the marketplace. Docker Data Center, we've got Docker in Azure Container Service. So we're doing a lot of engineering work, and obviously to include Docker in Windows. So while the container support is different in the kernel level on Linux and Windows, the benefits as a developer and an operator is that you have consistency in terms of the tooling that you use to build and manage containers, whether Linux containers or Windows containers. So if you're running a Windows container, it's still Docker run on a Linux container. So it'll eventually, or is already starting to get to the point where we now have orchestrators like Kubernetes or Docker Swarm, which can then orchestrate containers over mixed clusters of Linux and Windows. So starts to make life a bit easier and kind of blur the lines between like a Linux sysadmin and a Windows sysadmin team in terms of what they can manage in a collective cluster. Now I will go back to that. Slide. All right. So in terms of the support for Docker on Azure, so I've got another slide which will go over the compute services, but you can think of these services as really the Docker native services that we provide. So these are things like the VM extension. So we automate the installation and configuration of the Docker engine in Linux virtual machines. Really useful if you're using things like VM scale sets to build scaled clusters. We have support for open source container-based systems, so things like Deis or OpenShift from Red Hat that support Docker and Cloud Foundry. We've also got Azure Container Service. So Azure Container Service is your choice of open source orchestrator, whether it's Mesosphere DCOS, Kubernetes, or Docker Swarm. We're not doing anything custom to those orchestrators. It's the exact same open source code you can get from GitHub. It's the same code you can deploy on-premise, same code you deploy on another cloud. So really provides you, and that's really important to our strategy around Azure Container Service. And a differentiator for us against the other clouds is it provides you with a lot of flexibility, moving your workloads on-prem to our cloud, but to and from other clouds. So a lot of choice and flexibility there. And then we've also got a bunch of other marketplace offerings. So we support all the major Linux distributions if you want to run, supported Docker stack on Red Hat or SUSE, but we also have operating systems that are optimized for containers like CoreOS and Rancher. So let's have a look at see if I've got this slide in this deck, which I don't. That's cool. We can go to this one. All right. So I ruined the question because you've already seen the stickers, but this is like all the compute offerings that we have on Azure. So you can run virtual machines, you can run virtual machine scale sets for scale out previously only stateless solutions, but we just updated scale sets last week with capability to attach disks, so you can now do scale out stateful workloads as well. We have Azure Container Service, which we talked about. Azure Batch, which is targeted at high performance compute workloads. We've got things like OpenShift and Cloud Foundry, Service Fabric, which is our own microservices orchestrator, and things like App Service. And all of them, bar Logic Apps and App Service and Functions, support Docker as a deployment format. So while you might not go out and say, I'm looking for a Docker orchestrator, I'm going to choose Azure Batch, probably not the best choice. because it's a very specialized function. But if you are already using batch and you have developers that say, I have this high performance compute workload, it's already running in Docker, can you run it for me? Yeah, I can. So I can support that across all these services. So let's have a look at some stuff. So start off with, we talked about a Docker file. So this is a Docker file. It's a very basic application. And the construct of a Docker file, we start with a from, which says, I want to pull an existing Docker image as my base image, and I want to build my application on top of that. So you might pull RHEL or Ubuntu. There's a bunch of containers up on Docker Hub created by Docker that already have, I think most of them are moving to Alpine Linux, which is a really lightweight Linux OS, so very small, and they're pre-installing binaries. In this case, we've got Node 5.11. So we're saying, get this existing Docker image from Docker Hub, and then I want to execute these commands in that container. So I want to install my dependencies, my Node dependencies, and then I want to add my application code into this directory, and I want to expose the code on this port. And then when I do a Docker run, I want you to run node server.js to start my application. So we'll take that, let's go into this app. What is it, the results? So if we do a Docker build, PS, I am on Windows, but I'm running Docker for Windows. So what that does is Docker for Windows will install a virtual machine in Hyper-V if you've got Windows 10, and it's running Slimline Linux, so it enables me to build Linux containers on Windows. And I can also switch to Windows containers here. So I've got Docker installed, I've got a Docker file here, and we can do a Docker build. It's going to go off and build our container, and then we'll need to push it to a registry. So first we need to, so it's built this image here, it's just got an arbitrary GUID here. So first you need to tag your image. Good question on my, where are we? So I've got a Azure Container Registry set up, which we'll have a look at in a sec. All right, so that's tagged my image. So basically I've said, I want to tag this image. This is my registry, ignite-microsoft.azure containerregistry.io, and my Docker image is called example voting app result. And do a Docker push. That old chestnut. So now here's where you can see the layered file system come into play. So I skipped over that a little bit at the start. So Docker has the concept of layers. So I'm pushing to a private registry. I've already built and pushed an image up here before, so the layers already exist. So you can think of the first layer is that Node.js container, and then for every one of those commands, npm install x, npm install y, it's creating a new layer on that image. So when I do changes to my app, it's not pushing the whole, for example, 150 megs up to my registry, it's just pushing the diff. And if you're running on, if I'd push that to Docker Hub, it would have also worked out that I'm building from that Node.js container, which is already exist on Docker Hub, so it's going to point to that as well. So it gives that kind of flexibility in terms of the image layer management. All right, so we've got we've got a Docker app, we've done a Docker file, we've done a Docker build and push. So let's have a look at Azure now. So for starters, we updated the marketplace. So the content of this is exactly the same, but we've updated the look and how the Azure Marketplace works last week. So it's just a little bit easier to find solutions around technologies that you're looking for. So here you can see I've gone into the containers section. We've got a bunch of stuff that we've already talked about: Azure Container Registry, Docker Data Center, Azure Container Service, etc. It's an easy way to have a look at all the different offerings, click into them, and then that'll redirect you with the appropriate template to the Azure portal. So the other thing I'll first have a look at this Azure Container Registry, and then we'll run that container. So here's the Azure Container Registry. You'll find it under here. It's still in public preview. Currently, I think it's only in, I think it's in 2 of the US data centers in Europe and somewhere else, but that's the API endpoint for the container registry. You can still choose the storage of where your container images live to live in Australia East or Australia Southeast, but it's just hitting a different API endpoint. So still has benefits by putting those Docker images in a storage account in Australia. It's quick to copy to your servers. Some ones in West US, we can go in here, set up access keys, so username and password. Azure Active Directory support is coming. So that's Azure Container Registry. Now, if we go in here, so we built that app, I tagged it, and I pushed it remotely. So now to run that application, let's do a Docker run. We've got a -p that says I want to bind port 80 from the container to port 80 of my local host. Run that. So this is we'll have a look at this later. We'll look at this app in Kubernetes. It's a microservice application, so it's looking for the database container, which doesn't exist yet. But we can certainly hit the container as is. So there's my results app. So pretty easy to get running, and basically we're going to look at how we can take that app across some different Azure services and deploy that. So if I wanted to run in a Docker virtual machine, you can use the VM extension. So let's go into a virtual machine. Click into extensions. And we're going to add an extension and choose Docker. Just down here. So you're going to have to put a couple of bits of information in here. So this is the default Docker port. So when you do a Docker command, that's what port it's looking at. Because we're exposing it over the public internet for the extension, we're telling you here to provide some certificates and keys so we can provide a HTTPS connection. You can follow, I think, if we go back to this tab, if you click on this link here, running Docker with HTTPS, and go there, it'll give you this super long and boring tutorial on creating Linux keys and certificates. If you're automating something that you're standing up regularly, definitely go and do that. If you just want to spin up a virtual machine on Azure and run Docker, probably not the best experience. So I would recommend you use Docker Machine, which is a tool from Docker. So when you install Docker on Windows, you'll get Docker Machine by default. And to get a VM stood up on Azure using Docker Machine is as easy as this first command here. So I'm doing docker-machine, create, driver is Azure. You can use Docker Machine on other clouds and other virtualization platforms. And then all I have to provide is my Azure subscription ID and the name of the virtual machine that I want to create. You can obviously pass in a bunch of other variables. If you don't pass them in, it's going to do default, so you can specify where you want it provisioned, what virtual network you want it attached to, and all that kind of stuff. So I've already provisioned it, and now to switch into that environment, we'll do Docker machine environment Ken machine, and it's going to configure Docker in this in their shell to use that, and then we just have to run this command as well. So now, so I did a Docker run before, that was in my other window. So Docker run port 80, and is it ignite Microsoft.azure cr.io/. All right, so same command I ran before, but now because I did Docker machine and I've logged into this Docker machine, it's actually going to run it up in the virtual machine on Azure and not on my local host. So let's go back to that environment. That's fine. So Docker machine will go and create a resource group called Docker-machine. We go in here, we can see it's created all these default settings because I didn't specify anything, and we want to go into the virtual machine, and we can then just grab public IP address, and we go there, we've got the same application. So kind of highlights the benefits of using Docker. I can run exactly the same as my machine as it did on a virtual machine in Azure, as it would on a virtual machine in Hyper-V or VMware or another cloud environment. So a lot of control over the application, how it's deployed and how it's managed. So that's virtual machine deployment. The next thing I wanted to talk about was Azure App Service. So with Azure App Service, I think about November, we announced preview support for Linux on Azure App Service, and the technology that we're actually using is Docker to deliver that. So when you specify a Linux Azure App Service account, we can come in here, and I can specify, if I specify a built-in runtime stack, so these are the container or the runtime formats that we support in Azure App Service that are going to provide you like a proper platform as a service style experience. So when you choose one of these images, you can also then specify where your Git repository is for that code, and then it'll do the Docker build, Docker run, all that stuff for you. But you can also, because we're using Docker technology to deliver that service, it's very easy for us to allow you to run images from Docker Hub and also a private registry. So I've got the exact same app here. Put in my details to log in because I've got the private secured registry on Azure, and we haven't changed it, so we don't need to update it. And if we hit this link, so this one, I don't think they're currently preloading the application. So from what I see, from when I've tested this, you hit the app and it takes a little bit to load, which leads me to believe when I hit it, it's pulling down the Docker image. It's not available straight away. So you can see it loads up. So yeah, just something to be aware of if you're testing stuff out, especially if this is quite a small application. If you've got a big Docker container, don't be too scared away if it doesn't load up straight away. In this though, I can scale out my app service plan to other nodes. So it's only on that kind of initial pull that you have to wait. If you've got a scaled out cluster, that'll be good after your initial pull. So next is Azure Container Service. So Azure Container Service, I'll go to this deck. All right. So Azure Container Service, talked about before, fully open source. We support the three most popular Docker orchestrators. So DCOS from Mesosphere, or the Apache Mesos project, Docker Swarm, and Kubernetes. So all exactly the same as you can deploy on-premise or other clouds. And also coming is support for Linux and Windows containers through Azure Container Service. And it's supported on Azure and will be supported on Azure Stack when that's available. What is behind Azure Container Service is Azure Container Service Engine. So Azure Container Service Engine is a fully open source project up on GitHub. It's actually a project based in Golang. And what we are essentially doing is taking a bunch of input parameters like your subscription, what VNet you want, what cluster, what orchestrator type you want, and we're creating Azure Resource Manager templates on the fly and a bunch of dynamic scripts to provision that cluster for you. So if you run Azure Container Service, it's prescriptive in terms of how many masters you can have, limits on how many nodes you can have, what base operating system it uses, which I think Ubuntu 16.04. So if you wanted to use a different operating system, or if you want to do a different kind of scale-out architecture, you can go to Azure Container Service Engine and you can grab the same code that we've got in the back end, and then you can customize it to whatever your needs are. And it's upstream, so in true open source fashion, you'll find new features here first. So we don't have Windows container support yet on Azure Container Service if you're going through the portal or command line, but that is supported, well, it's available as a capability in Azure Container Service Engine. So if you want to play around with Windows container support, I think we've got it coming on Docker Swarm and Kubernetes as a starting point. There's already pull requests merged in the project, so you can test that code out if you're looking to run Windows clusters as well. So let's have a look at Kubernetes, because obviously that is my fave. Now, recommendation if you're provisioning a Kubernetes cluster is you use the command line, because if you use, so the new command line, AZ, if you run the AZ command line to provision your cluster, it'll do a lot of stuff for you. So if you want to go through the portal to provision one, you have to provide an Azure Active Directory service principal and some details. The command line will automate the creation of that for you if you don't have it already. So it's just an easier way to get going. We also, let's go here. So AZ, ACS, you do create orchestrator type and specify Kubernetes or Swarm. The other thing we do in the command line, if you're connecting to a Kubernetes cluster, Kubernetes uses a kube control, is their kind of command line interface to get that. So we make it easier. You can SSH to the cluster and pull it down and stuff, but we make it really easy for you by providing that in the command line. So if you run install CLI, it will go and pull that command line for you, put it in your path directory on Windows or Linux or Mac, whatever operating system you're using the command line interface for Azure. And then you can also get your credentials from there as well. So get credentials, and so that'll pull down into the default directory that kube control will look for your credentials to automatically log in. So if you run that ACS create, you create your cluster, install CLI and get credentials, and you don't put any parameters in there. You'll then be able to just run a kubectl proxy. So that's using kubectl, the command line we've downloaded. It's using the credentials file, which has got the keys for our cluster, and it's creating a proxy on localhost 8001. And we can go in here to our cluster, and we can see our cluster. So if you're just starting with Kubernetes, once you're up to this point, really easy to deploy a container. You can obviously get in and hack some code, but you can also use the UI and just specify our container image location, so our repository and our container image, and spin that up. But what I wanted to show you is when you're running Docker on like locally or one virtual machine, pretty easy. If you want to run like a multi-service application and they're sitting on the same node, that's cool. You can share localhost networking. But when you're talking about deploying production workloads across tens, hundreds, thousands of more nodes, you have to solve problems like service discovery, networking, attaching storage, things like that. And that's where you would use an orchestrator like Docker Swarm or Kubernetes or DCOS to automate those capabilities for you. And the concept for all these orchestrators is that you declare the state of your application. So the declarative, you say this is my application. It consists of these 5 containers. They use these images. They need this kind of persistent storage. They need these networking interfaces. Make it so. That's what it goes and does. So we've got the example voting app, which is a Docker demonstration app. So I just forked it from the Docker repo. I've got a session on Thursday which will go into detail on how to build the full stack end to end. But all the information is in this repository if you want to go and deploy the example application to Kubernetes. And it's going to look a little something like that. All right. So been using Visual Studio Code, pushing that up to GitHub. In this example, I've got a full continuous integration, continuous deployment pipeline set up. I'm the open source guy, so I built that with open source stuff. So instead of VS TS, which you can definitely use, and it's got integration into ACS, I'm using Jenkins. Then we're building those files on Jenkins. We're pushing them up to Azure Container Registry, and then deploying them in Kubernetes. So the example application is a very overcomplicated but simple application. So it's got 5 effectively microservices. We've got a voting service which is in Python. So just give you 2 options to click. We've got, once we vote, it then puts that vote into an in-memory cache, which we're using Redis. And then there's a .NET Core worker service, which is going up to the cache and getting those results, putting them into a Postgres database, and then we're displaying them on a Node.js results app. So super simple. You get 2 options to vote, and it's displayed on a result page, but we've got a bunch of stuff plugged in there just to show the flexibility of using Docker, because these are all Docker containers, so we're building them the same way, we're deploying them the same way, we're managing them the same way. And then we'll also have a look at OMS as well for container logging. So if we go into here, so who's using VS Code here? Hands up. Okay. Hopefully more soon. So VS Code it's our open source version of Visual Studio. It's available on Mac, Linux, and Windows. So same experience regardless of your operating system. It is fully open source, so if you want to get deep and dirty and write your own extensions or hack on it, you can. You can do pull requests to the repo. But it also has, regardless of whether you're doing .NET or any open source technologies, a lot of cool extensions, like we've got a Docker extension. So we looked at the Docker file before. The extension will go and create that Docker file for you. So if you've got an existing .NET Core app, you can open it up in Visual Studio Code and use, now you can see what I'm talking about. All right, so here's the Docker extension. So if I ran that and I didn't have a Docker file, create one for me. So it really easy, make it really easy to get going. Also, you don't need to exit out to the CLI to do a Docker build, Docker push. You can do them in the integrated terminal. You can also run Bash on Windows here, but the extension will also run that for us. We also have native integration to Git, and if I save my file, it'll pick up a change. Write a message in there for our commit, and we can do a git push straight from Visual Studio Code. And that is going to take any changes in my repository. So that whole repository we looked at in GitHub, it's going to push the differences up. If I stop wasting time talking and we go over to Jenkins, we can see that Jenkins has seen those changes on GitHub, and it's now kicked off a build of my application. So go in here. So this is a pipeline. I've got the code up on the repository. It's pretty simple. We're doing a checkout of the code, and then the app consists of 5 containers, but 2 of those containers we're just pulling directly from Docker Hub because we're not putting any code in them. So that's the Postgres container and the Redis cache. So we don't need to make any changes, so we can just pull them straight to the Kubernetes cluster. The other containers, so the results app, the voter app, and the worker app, have got code in them, so I want to build them when I make changes. I'm then doing a deployment into Kubernetes, and if we go, so here we're just pulling that repository, and that's a fairly simple script. We're saying this is my private Azure Container Registry. Log in and do a Docker build for these folders. So pretty simple, and then that's going to kick it off, deploy it to the Kubernetes cluster. So if we go back here, we can now see our applications deployed. So we've deployed all our containers. We can also see here some of the kind of declarative functions that you can do. So I can declare that different services in my application, I want to scale them out independently. So for the result app, we've got 4, but I can edit this directly from the UI and say, instead of 4, I want 8 replicas. So now the declared state is 8, actual state is 4. If we refresh, it's probably scaled up already. So it's up to 7. So it's pretty quick to start up those additional containers. So really good if you're scaling out workloads dynamically with load. If you want to trigger that scale out function via something happening in your app. So now, if we go to services, some of the other things that we're doing on Azure Container Service is we're integrating those orchestrators into the Azure environment. So in this case, I've scaled out 8 containers. Kubernetes has a concept of a service, which is like an internal load balancer. So as I scale up, scale down, start, stop containers, it's going to load balance across that results service, for example. And then Kubernetes has gone out to Azure and say, I want to provide an external IP address for this service. So it's created a public IP address in Azure. It's created a load balancer in Azure. And then it's actually load balancing all those containers for us. So good example of the integration. Although they're fully open source stacks that you can deploy anywhere else, we're doing a lot of native Azure integration to make them run better on Azure and more seamlessly. So if you run that somewhere else, you still have to go and do that additional stuff. So automating that for you. So that app, I have actually already exposed those IPs. So if you want to vote, you can on your phone. You can go to vote.unazure.io and vote for beer or pizza. Tough choice. I'd probably start with beer and move to pizza. So I'm going to vote for beer. Then if you go to results on Azure, we'll see the results here. So some people are voting, thank you. And you can see that, that's dynamically changing. It's going through that overcomplicated, simplified app to update the votes in the database, and beer is the superior winner. Cool, so one thing I also had on this cluster which was existing before I deployed my application, is I had a couple of containers which are running the OMS agent. So Operations Management Suite, you can think of, if you haven't heard of it, it's like the evolution of System Center, but it's cloud-born, it's software as a service. So the service runs in Azure, supports Linux and Windows, supports Azure and AWS and other cloud providers. So it's truly a cross-platform bunch of tools. So we have log analytics, we have automation capabilities, we've got security introspection capabilities, and the last one is backup and disaster and recovery. So for this example, I'm deploying the OMS log analytics solution, which is actually built on a mostly open source stack. So if you're familiar with open source logging technologies, we use FluentD as the agent on Linux. We do a lot of contributions to the FluentD project as a result. So what that is going and doing, a daemon set in Kubernetes is a concept that says, I want to run one of this container on every node in my cluster. So perfect use case is logging or monitoring examples. Makes it really easy to install a logging agent or a monitoring agent or something else on all of your clusters, all of your nodes in a cluster. So that is going to go out and pump my data out to Operations Management Suite. And in Operations Management Suite, we have a container solution. So if you go to this little shopping solutions gallery section here, you can enable the Docker add-on for OMS, and that's going to basically aggregate all the logs that we're pulling from the containers. It's also going to grab a bunch of container performance metrics as well. So important that when you're deploying large-scale Docker-based applications, that you're able to monitor them easily and get insights and take action upon those insights, and that's where we provide native integration into Operations Management Suite as well. So let's go back to this one. All right. So to wrap up, awesome, old slide. So wrap up, I just kind of wanted to sum up like what we're doing around open source. Docker is just kind of one area, very popular and interesting area, but we're very big on open source in general. And ultimately it's about choice and flexibility of what you want to run. we want to make Azure a really great place to run that, whether that's .NET or Java, whether you want to do Docker containers or virtual machines, or whether you want to do full platform as a service capability. So, support for things like Node.js and Python in app service that we looked at. So you can run any language you want in app service if it's in a Docker container. But if you don't want to have to worry about doing Docker builds and managing a pipeline, and you have Node.js code or Python code, then app service will do all that for you. We also support a bunch of open source databases and middleware stacks. So HD Insight is our big data solution based on Hadoop. So very popular offering. And we support every Linux operating system out there, any major distribution, and also some of those container optimized operating systems like CoreOS, Rancher, etc. So in terms of how we're approaching open source, so we're enabling it on things like app service, we're enabling you to run things like Linux virtual machines, but the more interesting areas that we're really pushing hard on open source at the moment is integrated solutions. So case in point is Azure Container Service. So we're working on full open source stacks. HD Insight is the other really great example. So full open source stacks, exactly what you could run in on-premise or in another cloud, but we're automating it a lot for you. So if you would go and deploy a Kubernetes cluster or a DCOS cluster or a Swarm cluster on-premise, it's pretty complicated. You've got to install virtual machines, you've got to install dependencies, you've got to do a bunch of configuration, create those certificate key files, which I hate, and we automate all that for you. So it's about providing you with the tools and technologies that you want to use, but making it really easy to use them as well. We're also releasing a bunch of stuff into open source, so PowerShell is probably the most notable recent one, and .NET Core as well. And we're participating in a lot of communities, so Docker's obviously one where we're highly active, as well as Linux kernel and a bunch of languages and other frameworks. So I talked about the operating system support, so major distros, RHEL, SUSE, Oracle, Ubuntu. We've got pretty much everything that you're probably using. And we're even now have a bunch of new stuff, which you're into, if you're into containers and stuff. Things like ClearOS from Intel, so we're the only cloud provider to currently provide that. I'm assuming more will provide it shortly, but kind of shows the change of strategy for Microsoft and how how into open source we are, how aggressively we're going about supporting all these different operating systems and frameworks that you want to use, and make it a really great place to use them. So in summary, we had a look at two main things. We had a look at how you can run Docker on Azure. So whether that's in VMs, using things like VM extensions or Docker Machine. We had a look at the Docker support across the compute ecosystem, which is pretty much all of our services support Docker as a deployment artifact. And we had a look at app service as an example. Had a look at Azure Container Service and specifically Kubernetes. And we also had a look at some of those supporting technologies like the Azure Container Registry for a secure private registry, Operations Management Suite for log aggregation and analytics. And we had a look at support for things like Jenkins and VSTS as continuous integration, continuous deployment pipelines to support Docker on Azure. If you want to, so as I said earlier, if you want to see how to build a Kubernetes cluster on Azure Container Service from scratch to the demo I just did, I've got a session on Thursday. So we'll start with nothing, build Kubernetes, build Jenkins. I promise it'll be done in less than 60 minutes and you'll be able to do it really easily yourself. So if you want to have a look deeper, certainly come along to that. So again, do your Ignite feedback surveys, but please also fill in the akm.ms/OSS feedback survey. We're keen to understand what people are looking for in Australia and New Zealand, where we can improve, what we can do better for you. If If you're not on Azure, you're probably not at this conference, but if you aren't, you can try it at that link. And if you hadn't seen, we've got a bunch of massively open courseware available on openedx.microsoft.com. So has anyone seen this yet? A few, not many. Recommend hitting it up. So especially if you're looking to get certified on the Azure certifications, you can get basically the full course that you need to get that certification on demand, free. I think if you pay, I think it's US 100, might be AU 100, but you will get access to sit the exam as well. So it's like we're doing a promo on discounted exams. Yeah, so hit them up, and that is me. Any